Okay, at this point in your math career, you've probably studied trig functions and how to evaluate them. And now you've gotten to the point where you have to evaluate inverse trig functions. For some people, it's kind of a struggle. It can be a little bit confusing. And hopefully this video with its examples will clear it up, make it a little bit easier for you. So let's first start with a simple example. And it's find the arcsine of 1/2. And notice I've written it in both ways. Arcsine is the same thing as inverse sine. I actually prefer arcsine because inverse sine to me looks kind of like the reciprocal. If you take the inverse of an exponent, it's basically the reciprocal. So I don't use it too much, but you'll see it used quite often, so I've shown both of them. But anyway, what is it really asking? What they're basically saying is, what angle or angles, if you took the sine of that, would equal 1/2? And what I like to do is just simply use triangles. If you recall from trigonometry, the sine is simply the opposite over the hypotenuse. Or if you were looking at the unit circle, it would be y over r. So what I like to do is I just like to draw all the triangles and work backwards. So let's do that. Okay, here's one triangle, quadrant 1, quadrant 2, quadrant 4, and this is quadrant 3. Of course, these are all right angles. Okay? And then what I say to myself is, look, we're looking for the arcsine, which is opposite over hypotenuse. Okay? So I'm going to write opposite over the hypotenuse, opposite over the hypotenuse, opposite over the hypotenuse, opposite over the hypotenuse. Okay? Those are our 4 options. Then, of course, what you have to be careful about is that some of these are negatives. So, of course, this is a negative value down below, and this is also a negative value. These are x values. I'm sorry, these are y values, and they're both in quadrant 3 and 4 negative. Of course, the hypotenuse all stay the same. So let's take a look at our 4 triangles. In this case, it's opposite over hypotenuse, 1 over 2. So this is a possibility. Opposite over, this is a possibility. This one is negative, so we can eliminate this quadrant. And this one is negative, and we can eliminate this quadrant. So what are we left with? We're left with these 2 triangles. So of course the next step is, what are these values? Well, if you remember, let's take one of these triangles, this one, 1 and 2. We could use either the Pythagorean theorem, or in this case, we could just recognize that this is a 30, 60, 90 triangle. Notice the leg is half the length of the hypotenuse, which is a characteristic of a 30, 60, 90 triangle. So let's fill in the rad 3. And what we have here is we have a right triangle, 1, rad 3, 2, 30, 60, 90. And if you remember, this is 30 degrees, and this is 60 degrees. So we simply take this triangle and use it in our sample over here. And what we realize is this is a reference angle of 30 degrees. And of course, since this reference angle is 30 degrees, we know that this is 150 degrees. So our answer for this component is going to be 30 degrees and 150. Okay? Now, that's for one revolution. And also what we're going to do is we're going to add all the coterminal angles. So if we look at 30 degrees, its coterminal angle would also be 390 degrees. And if we keep going around and around, keep adding 360, 360, we're going to end up with an infinite number of solutions. Similarly, if we take 150 degrees and keep adding 360, 360, 360, or subtract 360, 360, 360, we're going to get an infinite number of other angles that are also going to work. So our final answer is actually going to be 30 degrees plus n, which is an integer, times 360 degrees, which represents all the possible coterminal angles of 30 degrees. And 150 degrees plus all the possible coterminal angles of that, which is 360 degrees. And this are all the possible solutions for the arcsine of 1/2. Okay? Now let's look at a couple more examples, and hopefully this will make it even simpler for you. And our second example is the arctangent of 1 is equal to x. And of course, this time I left the range of values that x could be of 0 to 360 degrees. That way we won't have any coterminal angles. Okay? Again, what I do is I draw the coordinate plane. Okay? I draw the 4 triangles. 1, 2, 3, and 4. Okay? And the arctan of 1 is, of course, the same thing as 1 over 1. And arctangent, or tangent, is opposite over adjacent. So what we're going to do is opposite over adjacent, the opposite over adjacent, opposite over adjacent, opposite over adjacent. And again, we label all the negatives. This along the x-axis is negative, negative. And along the y-axis, this is negative and negative. Think of it as if you were plotting points. These would all be negative values for the x's and the y's. This would be positive for the x's, but negative for the y's, etc. Okay, and there's all our tangent values. So where is tangent positive? It's positive here. 1 over 1 is 1. It's negative here, so we're going to eliminate that. That's opposite over adjacent, it's negative. Negative 1 over negative 1 is positive, so that one is actually a possibility. And then negative 1 over 1, we eliminate quadrant 4. So these are our two solutions. So let's again take a look and find our reference angle. By drawing a triangle. This is 1 and 1. And of course you probably can recognize that this is a 45, 45, 90. This is radical 2. Okay? Therefore, the reference angle is going to be 45 degrees there and 45 degrees in quadrant 3. And so our solutions are going to be 45 degrees for this triangle. And then this is 180 plus 45 is 225 degrees for our other angle. And notice both of these fall in the given range. Okay? And the next example, again, I wrote it as the inverse sine instead of using arc sine, but it's the same thing. Okay? Again, and notice that I'm going to use radians in this case as I put my interval from pi halves to 3 pi halves. Okay? So I'm going to draw my grid and my 4 triangles. 1, 2, 3, 4. Now in this case, I'm going to go directly to the interval. Where is pi halves? Pi halves, for those of you who might be more familiar with degrees, is 90 degrees. And this is 270 degrees. So that is going to be from 90 to 270. We're only going to deal with the left side here. We're not dealing with quadrants 1 or 4 because that's the range that was specified. Okay? And again, we're going to use sine as opposite over hypotenuse. And the opposite side is going to be rad 3. The hypotenuse is 2. The opposite side is rad 3 from this angle. And the hypotenuse is 2. This is negative, okay, which means we're going to eliminate this triangle. And what are we left with? We're left with this quadrant and that angle. You probably already recognize that this is going to be negative 1. This is a 30, 60, 90 triangle. This angle, reference angle, is going to be 60 degrees. So our final answer is going to be, and actually is going to be 120 degrees. Of course, they want the answer in radians, and the answer in radians would simply be we convert this to 180, which is 2 pi over 3, which falls in between there. Make sense?